Students, now we will see that another one more problem in image compressions. In the last session, we have seen that image compression using Huffman algorithm. Let me show that this is the problem we have seen last time, where we got all these symbols with the probability values. See that these are these steps we followed, and we computed what is the coding efficiency in the system. Now let's see that one example. See, here I have given one image. 1 minute. See, here we have one image. So one aerial image is given, some satellite or aerial borne image is given. So here I just want to see in particular this point. Okay, here what is the pixel values in these particular locations. So I just zoom into the image. We got these are the gray level values in these selected locations. You can see that here pixel values having different ranges. Some of them are in black, white, and some of them intermediate to black and white. Some gray shades are there, and we can view the same thing in terms of values. See here, which is having some 170, 28, 80, 85 like that. So many times I said that images are nothing, it is a matrix. That's what we discussed in image transform in unit 2 also. So now in these small portions, not only small portions, entire image is like one matrix. And I selected a portions. In that also you can see all the matrix elements are there, some values are there. So where this all minimum 0, maximum 255. So that means you can infer that it is a 8-bit image. See here it is a black, which is here white, that is a 0. Next here we have one white. The corresponding location is 255. And again here black is there, so we can say it is a 0. Next to that it is a white, so it is a 255. So we have here all the values are correspondingly related. So now we will take one more problem. The problem statement is, for the image shown below, compute the degree of compression that can be achieved using Huffman coding of pixel values. They mention that image is given, and if you see that where is the image, that's nothing, matrix is given. So here, so image pixel values are given as some matrix. So what is the size of the images? It is a 4 cross 4. So image size is 4 cross 4. So 3, 3, 3, 2, 2, 3, 3, 3, 3, 2, 2, 2, 2, 1, 1, 0. So we can see that the range of pixel is from 0 to 3. So 0, 1, 2, 3. There are 4 pixels in this image, that is a matrix. Okay. So let us assume that it is actually one image, a small image, which is having values of pixels from 0 to 3. 0, 1, 2, 3. So for this, we have to calculate what is the Huffman coding compression ratio. See that I told if we apply a compression algorithm, we should know what is the probability of pixels, that is source symbols. In the earlier, that is previous problem, So they have given 6 symbols with probability values. Here they don't give probability values. So we have to compute the probability values from the pixel values. So what is the probability is nothing. It is a occurrence, a number of times the pixel repeated in the image. Okay, that is the frequency of that particular number. Okay, so we should not get confused. Frequency means frequency of the image. I say that I mean that how many number of times the particular pixel value repeated. Okay, that is occurrences. So number of occurrences. So what is the number of occurrences of 0 and 1, 2, 3? Okay, so that you can calculate what is the probability value from that. See that what is the total occurrences. That means what is the total pixels. I say it is at 4 into 4, so that it is 16. So 16 pixels are there. So 16 pixels are there. Among the 16 pixels, some pixels are repeated. Okay. See, 0 is only one time, and 1 is 2 times. 2 is 1, 2, 3, 4, 5, 6. Yes. So 2 is 6 times. Let me write here. We can avoid the confusions. So 0 is 1. And 1 is only 2 times. Okay. 2 is 6 times. And 3 is 1, 2, 3, 4, 5, 6, 7. Totally 7. So 7 times it repeated. So 3, pixel value 3 repeated 7 times. So let us add this all. 2 1s 3, 7 plus 3 is 10, and plus 6 16. See that pixel size is, pixel count is 16. Okay, so all adding all these value, we will get it is 16. And matrix size is, image size also 4 into 4. That is 4 cross 4, which is also 16. Now we got that is values were tallied. Let's move. Yes. So what is the step? First step is we have to find the probability of occurrence of the pixels, because it is not given in the problem. From the matrix value, pixel values we are calculating. That's what we calculated in previous slide. So pixel value of 0 is occurred only one time, so that only 1. So now we are going to calculate what is the probability. So probability is equal to what is the occurrence of the particular pixel to the total occurrences. So what is the total occurrences is 16. So 0 occurred only 1. So 1 over the total occurrences. Okay. So P of 0 is 1 divided by 16. Next I take a pixel value 1, which is a P of 1 is equal to, we found pixel 2 is, sorry, 1 is 2 times in the image. So 2 divided by 16. And the third pixel is 2, which occurs 6 times. So 6 over 16. Now the pixel value 3 is, P of 3 is equal to 7. That is 7 times pixel 3 is repeated in image. So 7 over 16. Okay, so that in the step 1 we calculated probability of occurrence. Next, now we will construct the Huffman code. That's what we know very well. So we have to arrange the symbols in terms of a descending order. See that 7 by 16 maximum value, 6 by 16 next to that, 2 by 16 that is the third lowest, and 1 by 16 that is the least in probability values. Corresponding symbol also I have given here. So pixel 3, 2, 1, 0. Okay. So the first column represents that. What is the symbol here? Second column is P of K. That is the symbol probability values. So 4 symbol probability values I have given. I said that one cross checking, that is if you add all these probability values, that should be equal to 1. Okay, so only we checked. Okay, now I will check again. See that 7 plus 6, 13 plus 2, 15 plus 1, 16. 16 divided by 16, 1. So that here we got conclusion our procedure is correct. We calculated probability values in correct manner. Okay. Now what is the step? Second step is we have to calculate the that is last two symbols of probability values. We have to add these two symbol probability values. So now what is the last one is 1 by 16 and the 2 by 16. So now I add these two. Okay, so these two symbols are going to be added. So I assign the probability is, that is a binary value is 0 for the 2 by 16, 1 for to the 1 by 16s. Now I am going to add the result is 3 by 16. Okay, so that you compare that 7 by 16, 16 by 7 by 16, 16 by 16 or 2 existing. New that a compound symbol probability value is 3 by 16. So this 3 by 16 is comparatively lower than these two symbol values. So that in descending order also no changes. See that 7 by 16, 16 by 16, this compound symbol which gives probability is 3 by 16. Okay. Now I take last two symbols. Now I take these two last symbols, going to add. So I assign the highest one is 0, lowest one is 1. I added that. So just to check it, 6 by 16 plus 3 by 16, if you add, we get 9 by 16. So the existing is 7 by 16, which is less than this 9 by 16. So that the compound symbol probability is higher than the existing one. What is that? That is 7 by 16. Okay. So in descending order arrangement, so shuffling will be there. So this compound symbol goes to top 9 by 16 and the existing symbol is 7 by 16. Finally, we got two symbols, because until to get the two symbols at the last, we have to continue this summation of least two symbols. So now 9 by 16 is I assign 0, 7 by 16 I assign it is 1. Okay. Now we have to make a code assignments. So code word we have to assign. So now I trace that 0 1 1 is there. See, I just I change the line. So symbols are 3, which is here, symbol 2, which is here, symbol 1, which is here, symbol 0, which is here. So after multiple time of addition of everything, only one symbol is coming here. Okay. So 7 by 16, which is actually from symbol 3. What we coded is 1. So we coded it by 1. So that I take 3 is here, it is 1. Single bit. Now 9 by 16, which is a binary value of 0. Let's trace back. We have to go back to the source. Okay, source is here. Source symbols are here. Out of 4, 3 we concluded. Only 2 1 0 is there. Okay. So now we will trace back. 1 minute. I change the color. From here I trace back. Okay. Now it is having 2 branch. See, from 0 we get 2 branches. One is here, one is down. So first I take a upper one, that is a 0, which is directly goes to symbol 2. Okay, see here. Okay, so that is 0 0. So I write it is 0 and 0. Okay, and second symbol is over. So first over, First one over, second also over. Let's take a trace again. I change the color. So 0 coming down. Already the upper portion over, the lower branch I consider. Okay, if I come here, it is 1 is there. Again it goes to there. Then further we have two branches. First I close the upper one because it goes to one symbol. Okay, so yes, now we got a 0. So I write here first is 0. Next is 1. 1. See that how I am writing. Last is 0. Okay, 0 1 0. So we got a symbol coded. Next is third one. Sorry, lost symbol. Okay, again I'm taking here 0 coming down. So here lower branch gives the further symbol divisions. So upper portion already finished. So last symbol 0. Okay, so 0 I write here 0. See, please carefully do that because many times up to these steps in Huffman coding process, up to these steps we perform very well. So tracing the binary values for the code word, so where we make mistakes. Okay, that is we have to carefully trace it back. 0 0 1 1. So 1. See, I'm writing in these directions. Okay, from the here last symbols to source we are tracing. I'm writing here from here to 0 1 1. Okay, so least to most, LSB to MSB I'm writing 0 1 1. Okay, so now see that we finish the code word assignment to all these 4 symbols. Let's see what is the next. See here how to understand this compression ratio we achieved. The compression ratio here we got is 1.14. See that actually the compression ratio is here it is 2 divided by 1.75. Okay. So what is the meaning is the numerator represents data using fixed code word length. So we need 2 bits to represent these 4 symbols. But if you are using Huffman coding, this denominator represents that average number of bits per code. It is 1.75. See, if you are using fixed code word length, it is a 2. In Huffman coding is 1.75. Now, if you take this ratio, how much we compress the images is, it is around 1.14. Okay. So this is the compression we achieved through this Huffman coding. Okay, students. So till now we have seen the problems in compression ratio. So here we have two metrics to measure the compression level in what is the compression logic algorithm we are using. So we can check what is the amount of compression we have done through that algorithms. That is, we can say compression metrics. That's first one is the compression ratio. So it is a very important compression metrics in compression algorithms to measure the performance. And next one is rate. That is rate is it is a metric used to evaluate the performance of the compression algorithms, and this rate gives the number of bits per pixels used to encode an image rather than some abstract percentage. So what is the formula for a rate is that is bits per pixels. So we can say it is a BPP. So generally we used to denote it as BPP. So let's see that what is rate. So rate BPP is equal to 8 into output file size, that is in terms of bytes, divided by input file size, that is bytes. So why I used this 8 is because most of the grayscale images what we are using is 8-bit depth. That's 8-bit image. That's why I used here it is 8-bit. Suppose if we use 16-bit images, so there it will be replaced by 16. Okay, so that typical grayscale 8-bit image has a rate of 8 bpp. This is the board compression metrics. So till now we have seen two problems which described about Huffman coding algorithm and compression ratio. So we will have next arithmetic coding and some other coding methods also. Before that, here I have given some exercise problems for you to have a very good practice on compressions, that is using Huffman coding. The same problems, some problems you can use for arithmetic coding also. Okay, so whatever it is, now we will see these all problems, that is exercise for getting practice with the Huffman coding algorithms. So first one is this is the first problem, which if the original size is 256 into 256 pixels and each pixel is having 8-bit depth. So it is a 256 different gray level representation, and see it would occupy 65,536 bytes. We calculate that 256 into 256. So this 256 to 256 is giving this much bytes. Okay, how I used it is the bytes is each pixel is represented by 8 bits. So 8 bits is equal to 1 bytes. So that 256 cross 256, which will give 65,536 bytes. Okay. Suppose after compression it occupies 6554 F bytes. So now we have to calculate the compression ratio. So compression ratio means that one compression algorithm to the another one. Okay, that is, so we have to divide this. So before compression what is that, after compression what is that. So if you do this, you will get an answer for this. This is the compression ratio related to first problem. So second problem is that also we solved, that is using Huffman code. The image given is 8 cross 8. So that totally we have 64 bits. The problem is compress the following 8 cross 8 image using the Huffman code. I solved a problem, previous problem, with the 4 cross 4, totally 16 pixels. Here we have 8 rows, 8 columns. Okay, so totally it will give 64. So it will give 64 pixels. Then what is the task here is we have to calculate the probability of these pixels. So what are the pixel range here is, here we have a 0, see that zeros, and 1, 2, 3, and 4, and 5, and 6. So that totally 7 pixels are there from 0, 1, from 0 to 6. So totally 7 pixels. So we have to measure what is the occurrences of zeros, how many times of repetition for 0. So how many zeros? And 1s, 2, 3, 4, 5, 6. If we calculate, we can get a probability values. So that we can make what is the number of symbol is 7. So 7 symbols. So here it is. So let me say it is SK. So SK. So we will first you have to prepare the table which consists of one column is symbols, 7 symbols from 0 to 6. 0 to 6. Next one is the probability. So P of K or PK. So we calculated. So from that we will get suppose I say suppose I take it 6. Okay, so because it is very less in count, 1, 2. So 6 is the 2 times repeated. So that probability is 2 divided by 64. So 2 divided by 64. So like that, if we calculate all these pixel values, you will get the addition summation of these pixels would be equal to 1. That is a one cross check. Then we have to construct the Huffman code. So step 1, descending order, write all the symbols probability values in descending order, and compress add the last 2 symbols. So till we get 2 symbols left. Then come back to the source symbols by tracing the binary values. Then we will construct the code mode for each symbols. Then what is the, they are saying that only to compress. So we have to find the compression ratio. That is important. So calculate. So here you can measure all the parameters. What is the average length, efficiency, entropy, compression ratio, because you will get a practice. So calculate all these values. This is the second problem. And the third problem is this is what we already did in the first problems. So they are given symbols W, R, Y, G, B, O, and corresponding probability values also given. From that we have to find what is the Huffman coding, that is average code word length and efficiency, everything. Okay, it's very easy. And fourth is some interesting thing. Actually, it is not related to image compressions, because image means we have a matrix. Okay, here they have given some data. They have given some message. From this message, we have to make a Huffman coding algorithm. So the symbols, read the sentence, I love image processing. So I love image processing, some characters are there. So here, what is the message or symbol is, that is the characters. Okay, English letter is the, each letter is our message or symbol. So here you have to calculate, group the letters. So I, how many times? So you have to construct that. See, from that I can say I is 3 times. Okay, 3 times coming. And L is only one time. So L is one time. And O is 2 times. And V is only one. E is 2 times. And M is 1 time. A also 1 time. G is 2 time. E is 2 time. And P is 1. R also 1. C is 1. S is 2 times. And N is 1 time. So we have different letters, and we can calculate what is the occurrence of these letters. From that you may calculate the probability of these letters. Then you can find the Huffman coding for this all high low image processing centers. Okay, see that the same problem we can use it for arithmetic coding also. We see later how we can use this in arithmetic coding algorithms. Okay, so this are some exercise problems. So try to do this all. Okay.